Okay, so 10-1, we already have done inverses, right? And we even did stuff with quadratics and cubics. So we've played with this a little bit more, but we're just gonna like nail it down, totally get it. Okay, so let's start with this first little scenario. So it says, finding the inverse of a many to one function. That's hard to say, many to one function. So this is what that means. So remember when we first talked about inverses, they started with working with ordered pairs. Okay, so can you guys see those 5 ordered pairs up there? Or at least on your tablet in front of you. How do I go about finding the inverse when given ordered pairs? Just switch the x and the y, right? Okay, so would you guys all agree that the inverse would be 4, -2, 2, -1, 0, 0, 2, 1, and 4, 2. Okay, so the second part of this says, is the inverse a function? So how do we decide if it is a function or not? Okay, if it passes the vertical line test. So what I'm going to do is I'm going to go ahead and graph this so you guys can kind of like visually understand this graphically. Okay, so if I pull these points over here and graph this. Okay, I'll do, the inverse in blue. 1, 2, 3, 4. Then I have -1, 2, 0, 0, 1, 2, and 2, 4. Anybody take a stab at what that would potentially be as a function? Looks.
Absolute value. There we go.
Oh, it could. Well, I can't disagree. Yeah, it could be absolute value-y, or it could be parabolic. It looks a little bit more absolute value-y. So, anyways. Pretend my dots look pretty. There we go, that looks pretty good. So, is that a function by definition?
Yes.
Yes. Okay, it passes the vertical line test. Okay, now if I go and I plot the inverse points. Okay, so I'll do that in red. Those points are 4, -2, 2, -1, 0, 0, 2, 1, and 4, 2. Okay, now does the red function pass the vertical line test? No. Okay, so what we're going to do is we are going to restrict the domain of the red function so that the inverse does in fact exist. Okay, so if I go back to the blue function, tell me what the domain is. The blue function. What are the x values? Okay, so if we think about the domain, the x values are -2, -1, 0, 1, 2. And by the way, the range values would be 4, 2, 0, 2, 4. So if I do the same idea with my inverse, what would my domain be? 4, 2, 0, 2, 4. And the range values? -2, 0, 1, 2. So, tell me what, if you were just looking at these two, what did you notice? What happened? They flipped. Okay? So, the nice thing about the domain and the range is that they just flip. So, the idea here is that we are going to restrict our function so that the inverse is going to exist. Okay, so right here says the domain of the function should be restricted to x is greater than or equal to what? Okay, so Jaden just said 0. Did everybody hear that? Okay. Why 0, Jaden? Kind of. Ooh, I like that word, axis of symmetry. Although that's kind of an unnecessary thing, but I like the idea about it. Okay, so if we say only the values that are greater than 0, then which 2 points are we going to eliminate? Okay, so of the blue function. Okay, so if I just say greater than 0, then we're going to eliminate this side right here, right? Which, if I eliminate those 2 points, what points of the red function am I going to eliminate? So if this is the point right here, this point was negative 2, 4. So what was that point? If the inverse of negative 2, 4 would be 4, negative 2. So that would be this point right here, right? And then this one right here was negative 1, 2. So 2, negative 1 would be that point. So if I get rid of those 2 points. Okay, so do you see that by restricting the domain of the original function, my inverse function now exists? Okay, do you see how now the red passes the vertical line test? Okay, so that's what we're going to be working with today. Okay, so if we say x is greater than 0, now what are the ordered pairs for my inverse function? Okay, so I would just eliminate these 2 pieces right here, and now only kind of that right-hand side of the function is going to exist. Okay, make sense? A little bit? Okay, so let's work with a quadratic function. I don't like the one they use, so I'm going to use my own. So I'm going to call this number 1. Let's do 2x squared. Okay, so basically what we're going to do is we are going to, first of all, restrict the domain so that the inverse function does exist. Then we're going to figure out what the inverse is, and we're going to list its domain. Got it? Okay, let's start by looking at the graph, because looking at the graph makes it really easy to identify the domain and the range. Okay, so if I was going to graph 2x squared, what would it look like? Where's the vertex? Because that's a really important part of this. 0, 0. Okay, so I'm going to even list that and say the vertex is at 0, 0. Okay, then I can go and say, okay, what's my slope? 2 over 1. So to find some additional points, I can go up 2 and over 1. Right. Okay, so it makes this nice little parabola. Okay. So what we're going to do is we are going to start by restricting the domain of our original function. Okay? So kind of like those points that I did before, I'm going to cut off an arm. Sorry, that sounded really violent, but it got everybody's attention. Cut off an arm. Okay, so if I'm only dealing with this right-hand side, will the inverse function exist? Or will it not pass the vertical line test? Do you see what I mean by that? Okay, we'll turn on its side. Okay, so if I cut off the left-hand arm, okay, and only draw the right side, so let me just cut that off. What is the domain of this function now?
0 to positive infinity.
0 to positive infinity, perfect. So we're going to go from 0 to infinity By the way, what's the range of this function? 0 to infinity. So lowest value is 0, and it goes up to positive infinity. Everybody okay with those two?
Yes.
Perfect. All right, so now keeping that in mind, I'm going to, well, ignore it for a second, and algebraically find the inverse. So how do I go about finding the inverse of any function? Switch the x and the y, so I'm going to say x is equal to 2y squared. Okay, so my first step is going to be divide by 2. So now I have x divided by 2 is equal to y squared. Next step is going to be the square root. Okay, now here comes a decision. Anytime I solve a square root, I usually need a plus or minus, right? Do I need a plus or minus in this case?
Wouldn't you, because there's a positive x and one, the negative x, the negative y?
Let's look at the graph. I mean, think about the graph of this. What does the square root of x over 2 look like? Well, you guys have calculators in front of you. You know how to use them, I think. Do you know how to type in a square root of x over 2? I hope so, because you hit second and then this little square root button, x divided by 2. Okay, so if I hit graph, does that look like the inverse that I should get for this? That would make sense, right? The top half. Okay, if I had the negative version, let's throw negative in front. A negative square root of x divided by 2, what would that look like? It's the bottom half, right? Okay, if I graph both of them together, you can see that parabola just turned on its side. But remember, we only want one arm. Okay, so we're just going to have only the positive version.
Do we ever use the
Okay.
negative version? Or is it just easy
The
to
only
use?
time you would ever use the negative version is if you initially used the left arm as your function. Okay, so if we had decided we're going to restrict the domain and it's going to be negative infinity to 0, the left arm, then I would have used the negative. So you get to choose how you restrict the domain. Okay, so if we have a function like this and I say here's the answer, there's technically going to be 2 scenarios depending on the way you restrict the domain. Okay. I also need to list the domain and the range of my inverse function. So what's the domain and the range of the inverse function?
0 to infinity.
Okay, yeah. So theoretically these two would switch, but in this case they're exactly the same, so they stay the exact same. Okay, so just so you know, we could graph that and it would look like that. Pretty. How'd we do? Pretty good? Should we try one more? You okay? You look like you're gonna sneeze. Number 2. Okay, let's do one that's moved a little bit. Let's try x squared minus 4. Okay, so x squared minus 4. Let's start by graphing it, kind of think about what it looks like before we do any restrictions. At some point, I think that it will be possible for you to do the restrictions without using the graph. And maybe you're ready for it now, but I'm just going to graph it so you have a visual. If I have x squared minus 4, what does that look like?
I understand negative 4 after about 20 vertices.
Good. So we just take this parabola down 4 units, right? Okay, so if I was going to graph the entire thing, I would have a slope of 1 over 1. So I'd have another point right here at 1, negative 3, and then a third point over at negative 1, negative 3. Okay, so I'll let you choose. Do you want to use the right arm or the left arm? Right arm? Everybody's feeling right army? It's usually the stronger one. Alright, tell me what the domain of just the right arm side of this, oops, too much racing. That'll work. So what's the domain of just the right armed parabola? So it goes from 0 to infinity, so we're looking at just the x's. What is my range? Good, -4 to infinity. Everybody okay with that? Perfect. All right, so now I'm going to go ahead and algebraically find my inverse. So I'm going to start by switching my x and y. So x is equal to y squared minus 4. Okay. Add 4. And then square root. So would all agree the inverse, whoops, is the square root of x plus 4. And do I have a positive or a negative square root? Which one is it? Positive, right? Because I used my positive right arm previously. Okay, so tell me, what is the domain and the range of my inverse? What's my domain? From -4 to infinity. Good. And my range? 0 to infinity. Perfect. Everybody okay with that? Do I need to do another one where we have maybe like the parabolas move like left or right, so it's off of the y-axis? Do one more? Okay. Okay, so number 3, let's say the function is 2x minus 3 squared. Okay, so if I have this scenario, what is my translation? To the right 3, okay? So this parabola is moved to the right 3, so 1, 2, 3, so the vertex is right there. And I could draw the slope of 2, and I could go up 2 over 1, so a second point would exist at, what is that, 3, 2? So before I draw my left arm, do you want to do right arm or left arm? Right? You guys are all right-handed? Feeling righty today? All right, so what's my domain of my original? From 3, right? Because now it's over at 3. Yep. So it goes from 3 to infinity. And my range? Lowest is at 0, and it goes up. Good. Everybody okay with that? Okay. So now we do the algebraic part. Switch the x and the y. So x is equal to 2 times the quantity of y minus 3 squared. Now this one is a little bit different algebraically. How would I go about solving this one? Divide by 2. Ooh, yeah, okay. So this one I would have to take a square root first. So then I have the square root of x plus 2 over y minus 3. And then what's your last step? Add 3, good. So can we all say the inverse function is the square root of x over 2 and then a plus 3 at the end? Okay. So what's my domain of that? Good. From 0 to infinity. And what's my range? 3 to infinity. Oh, I forgot to graph my last one. Let's graph it. So for this one, let me just plot those points, by the way. So this point would be 3, 0, and this other point was 4, 2. So what is my inverse vertex going to be? 0, 3. So right there. And then my inverse point is going to be 2, 4. Okay, so can you visualize it? Turn over outside. Not too bad? Got it? Thumbs ups? Sidewayses? Bad. Halfway between medium and good? I'll take that as a thumbs up. Alright, so the second half of this is just working with Cubix. Okay, so x cubes. I'm just going to go straight into the example they have. I actually like that one. Okay, so for question number 5, we have 2x cubed, if you can read that or not. Sorry, it's a little bit mini. 2x cubed. Okay, so the first thing I would do is go and graph it. Okay, so what does 2x cubed look like? It's a John Travolta, and where is the vertex of the John Travolta? 0, 0. So I would plot 0, 0, and this particular John Travolta has a slope of 2. So to draw that, I would go up 2 and over 1, and then down 2 and left 1, and draw this John Travolta. So, now John Travolta's shape is a lot different than a parabola. If I take the inverse of the John Travolta and basically lay him on his side, is the inverse going to exist as a function? Yes, it is a one-to-one function. Okay, so the nice thing about the Cubix is that I do not have to restrict the domain. I can just go straight into the algebraic piece of figuring out what the inverse is. Okay, so switch the x and the y. And how would I solve for y? Good, divide by 2. So I have x divided by 2, and then what would I do next? Cube root. Do you guys all know how to do a cube root on the calculator, by the way?
You showed us once.
Okay, so just for reference on calculating, I guess, let's graph this one in the calculator, make sure you know how to do that. Okay, so if you go into your y equals, and clear out your other stuffs. Okay, so if we were going to, here, let me rewrite this in a nicer way. So our function is the cube root of x divided by 2, right? So to do a cube root, you hit math. Okay, so the math button is right below the green one. Okay, and the cube root is the third option down. So by the way, because we might eventually get there, you can also do other powered roots in this option. So see, number 5 has an x. So for example, if you're going to take like the 6th root of 20, you would type a 6 and then use option number 5 and then type 20 and it'll give you the 6th root of 20. Okay, so now that you know that, you're ready for radicals of all kinds. So we got the cube root of x divided by 2, and we should see a John Travolta on his side. Okay, what do you think? Looks pretty good? I like it. So let's draw our John Travolta over here. Where's the vertex of the inverse function? 0, 0. Okay, I have this point as a reference. This is the point 1. Oops. Sorry. Did you guys notice that I didn't go by the scale that already? Let's pretend this goes by 1s. Because apparently nobody else noticed. I just said 1.
Isn't it still same thing 1 over 0.5?
No, because it wouldn't be proportional. It only works if you're one horizontal unit away from the vertex. So any distance not 1 unit away will be, because the function is exponential. And so the curvature raises so much quicker, so it's like more bent, if that makes sense. differentiated, I guess. So pretend that this is the point 1, 2. Well, it is the point 1, 2. So what would my inverse point be? Good, 2, 1. Okay, and this one would be negative 2, 1. So this would just look like that. Okay. That's it. So, just so you know, I'm just going to throw this out there. It is possible. So we've been working with polynomials where you have stuff like, just for example, I'm just showing this. Remember how we did x plus 2, and let's just say x minus 1, and let's just say x plus 4. Okay, and pretend we were going to graph that. Okay, we just took a test on this. Where does it cross the x-axis? As soon as everybody takes it.
-2, 1.
So negative 2, positive, no, yeah, positive 1, and then negative 4. So this would look like a John Travolta that goes like this. Something to that accord. Okay, so if I took the inverse of that particular function and I laid it on its side, would the inverse exist? Would it be a function?
No.
No. So this could get a whole lot more interesting if I was asked to find the inverse of this and restrict its domain. Okay, for me to do that, I would have to like cut off this piece right here and start at this minimum value and only use part that's right on. Okay, so it could potentially get a lot crazier. But it doesn't get that much crazier because they only keep monomials for you today. Yay. So that's it.